Howdy and welcome back. So we'll go ahead and continue this lesson with a brief video on the motivation for relational databases. To begin this discussion, let's go ahead and reminisce on our student objects back from the binary files days, and we'll talk about them briefly here. So given a student object type defined as follows, we have two fields, last name, first name. Each is going to store a C-style string that has at most 255 characters. We said that this fixed width structure was very important in the rudimentary binary files that we were creating from this object. We mentioned with how a fixed width, we could essentially iterate or jump from one object's representation in storage to the next simply by seeking some number of bytes forward into that file. We discussed the importance of a map, so understanding the file or the structure of that file to interpret it appropriately. Contrast this with our introduction to delimited plain text files, where essentially we didn't have to specify upfront the lengths of the fields because each field was going to be delimited by a special character. Now remember the implications of this. If you wanted to go from one record to the next, we didn't have that fixed offset from one line to the next. Instead, we had to essentially look at each of the characters comprising the file and counting out some number of line feeds, because there was one record per line, in order to get to a specific line and begin reading, say, that storage representation into an in-memory representation in our programs. We noticed, this mixed variable length of the records had some implications when we were talking about, say, updating a record that was being stored in delimited form in plain text. This was very different than our binary file storage, where we could just simply go out to record number 5 because it's a fixed width, overwrite what's there. So yeah, two different things going on, but let's consider maybe some more kind of complicated scenarios here for serialization. So what if we wanted our student type to have variable length fields? Well, we kind of maybe alluded at one way we could go about this, but we'll see very shortly here that things are going to get complex very fast, and we'll quickly do away with this idea that maybe a fixed width format, a variable length format such as CSV, whose fields are delimited, isn't necessarily the proper approach here. So one thing I want to point out is if you attempt to write student objects of this type, notice here that C-style array was changed to a standard library string. If you want to write this out in binary representation, you're going to run into a couple of issues. And the reason is that where this standard library string stores its data is not going to be kind of encapsulated within the student object. It's going to live kind of out in a different area of memory. So if we just write this out as is without addressing that, we'll see that we'll have some issues when we deserialize this object back into its in-memory form. But we're done with binary files, so we're not going to worry about that here today. I understand that this week's videos are they're taking some time to get through. But if you want to try that and kind of experiment with it on your own time, it might be fun to see what happens. So let's go ahead and take this up one notch and say, okay, we have our student representation in our program. They have a UIN, last name, first name. Now I want to associate each of these students with the courses that they're taking. So the question begins, well, okay, first we need a representation of our course within our application. So we'll do some object decomposition here and come up with, okay, let's create a user-defined type called course. Again, I'm just using structs here for simplicity. A lot of these sorts of types should be created as a class with well-defined constructors and invariants that are maintained throughout the lifetime of objects derived from them. But that's not the focus here. The focus is at this point setting up with some relationships and saying how a relational database will help us store some of the complexities that might arise. So if we want to say a student has a course, in our in-memory representation, probably the most straightforward approach to this is going to say that Okay, I'm going to go ahead and create a vector within my student type. It's going to be called courses, and it will hold a pointer to a course. And you might be wondering why a pointer and why not a course? Well, each time we push back an object to a vector, a copy happens. So if we create, say, a course CS128 out there somewhere in memory, and then we were to push that back to a vector of just courses, the student's course vector would receive a copy of it, which means that if we were to mutate that original course, maybe change the name of CS128 to Intro to Computer Science 2 opposed to Introduction, or whatever the full official name of the course is by the time it's absorbed into the curriculum. If each student is simply storing a pointer to that object, all students taking that course are going to share that single occurrence of the object. So we only have to make updates in one place in memory to have those updates be reflected in every student's course list. And again, that's simply because with a vector of pointers to courses, we'd push back the address, and then we'd go ahead and dereference this course if we wanted more information about, say, each of the students' courses that they're currently taking. So with that kind of aside, how would we serialize, deserialize these objects? This gets complicated, right? And then the next, question might be, okay, so we have students, we have courses, who's teaching these courses? And, we're going to want to come up with some way to go ahead and associate an instructor with a particular course. So at this point, if we want to introduce instructors and associate them with a course, we might introduce a faculty type. And those faculty objects derived from this type might contain a vector of pointers to courses called courses taught. So what we're going to see at this point is that a student can have many instructors through their courses, and a faculty member can have many students through the courses they teach. And we'll start getting into some more interesting questions like how can we know what instructors a student has? How can we look at this through the relationship that both of these entities may share the same course? So the next step in our in-memory representation could be to do something like this. Maybe our courses should know about its students enrolled and the faculty members who serve as its instructors. And there are some courses that have multiple instructors that are utilizing some sort of team teaching. Hence here, I'm going to have a vector of pointers to faculty members, just like I'd have a vector of pointers to students, because a course can have many faculty associated with it, and a course will inevitably have many students associated with it. Now, at this point, you're probably looking at this going, okay, there's a ton of different associations going on here. A faculty member has their own list of course, a student has its own list of course, and now the courses have their own list of faculty members and students. How do we keep all of this straight? Well, that's going to be the responsibility of your program. So you'll have to implement functionality to do that. But let's go ahead and look at this from, say you've done all that. How do you write these out in persistent storage? How can you write these objects like a course object out and capture its associations with faculty and students? So, essentially what we've created now is this, there's a bunch of relationships going on across our objects, or objects of these types. A student can have many courses, a faculty member can have many courses, a course can have many students, a course can have many instructors. A student has many instructors, so faculty members, through their courses. A faculty member has many students through their courses. So maybe we're iterating through a vector of faculty and we arrive at my name. We look at my courses and I see 128. How could I find out what students are enrolled within my course? Well, we could access the students vector for that respective course. So we could say that through courses, I have many students. Likewise, a student could say, through my courses, I have many instructors. So we'll get into how to represent these relationships here shortly. But again, let's just look back at this question. How can we store such data in persistent storage? The relationship between objects of these types makes their serialization involved for plain text files or binary files, because this data isn't flat. There's a bunch of different relationships going on here across different types of objects.